Alright, so in this presentation I'm going to go over basic residential utility analysis. So we'll go over the difference between seasonal load and base load, how you calculate seasonal load and base load. We'll look a little, give you some sense of what a heating degree day is and what it means, what it indicates, and also how you calculate home heating index. So we're going to focus primarily on residential utility analysis here. What is a utility analysis? I mean, simply put, you're just analyzing the utility use or the utility bills of a house. You have to analyze all fuel sources. One of the purposes of doing this utility analysis is to figure out all of the energy that they're using and sort of give you a sense of how they can reduce their energy use and cost. So you need to know all of the different energy sources that they are using. So I want you to feel free to pause and think about some of the reasons why you would do a utility analysis, and go ahead and press play. So there are a number of reasons. You need to figure out, as I said, all of the different energy types of energy that is being used. A really important part of this is for energy auditing is to figure out how much they're paying per energy unit, so how much they pay per kilowatt hour, how much per kilowatt, and so forth. That's really an important consideration when you do your energy savings calculations, to sort of show them, like, if you whatever, add insulation or do whatever weatherization you recommend, you want to figure out how long it's going to take to pay for itself, how much money they can save over time. You absolutely need to know how much they're paying for energy in order to do that. You can also get a sense of sort of how efficient or inefficient a building is. With the more experience you have, the more you can sort of pick up on these things. But you also want to look at the energy use patterns. So when are they using the most electricity? Is it peaking in the winter or the summer or the fall or whatever? Are they using other are they using natural gas a lot in the summer? And if so, what does that indicate? So you want to look at your general use patterns. So sort of how they use them on a month-to-month basis. And just an FYI, you can do more advanced utility analyses, and a lot of times you can access hourly data and even 15-minute data and really dig in deeply to home energy use, but we won't do that in this class. So just to give you a little bit of a sense of how energy is used in a typical home in the U.S. Now, this is an all-electric home. It's in Pennsylvania. It's from the PA Weatherization Field Guide, but it gives you some sense of where energy is being used in a typical home. So you have space heating and water heating. I think a lot of people are surprised that water heating is such a big cost, or a big use, but it is generally in the 15 to 20% range. Whereas cooling, it depends on the climate. In this case, it's in Pennsylvania, so it's not a really heavily cooling dominated climate. So that'll change depending on where you are. Obviously, if you're down in Florida or up in, northern Maine, the heating and cooling profile is going to change. And then you have your lighting, refrigeration, clothes dryer, and other. And these are just some of your typical energy uses in a building. So let's start thinking about, I want you to really start wrapping your mind around how these different energy uses are used and when they are used. And specifically, we'll discuss seasonal load and base load. So this is really important. You want to jot down base load and seasonal load. So base load energy, or base load, it refers to the portion of your energy bill that really doesn't change from month to month. Now, it can change a little bit, but not significantly. Whereas the seasonal load does change a lot depending on the season, as the name implies. So you think the base load should be pretty easy to remember. You think of it as like the base, right? Like the foundation. You can see on this chart, this is a chart that shows from 1 year electricity use. So we got kilowatt hours on the y-axis, and then we have our month of the year, April, May, June through March, on the x-axis. Okay, and so as it goes up, that means your energy use is increasing. So you can see this is divided into base load in gold and seasonal load in orange. And you can see here that the base load it really doesn't change much from month to month. It goes up and down a little bit, maybe like 10, 15, 20 kilowatt hours. But that stays pretty standard, so it doesn't matter if it's February or July. The energy, the equipment in the house that's using that energy, it's basically the same. Whereas this seasonal use, and this is an all-electric house, in the summer it peaks, right? Because air conditioning, cooling. Remember, there's not a whole lot of cooling in this climate. And then the winter, a lot of heating costs. Now this is more of a heating-dominated climate, and so there's a heavy seasonal load, seasonal heating load. Okay, so you can see the seasonal load goes up depending on the season. Really typical, you have your shoulder months, your fall and your spring, where there's not much seasonal load, peaking in the summer and the winter. And then your base load is pretty much the same the year round. Okay, so hopefully that gives you some sense of the difference between a seasonal and a base load. So how do you calculate the base load? So you can actually calculate the base load from utility bills, and this is something you will do in this class and in your lab this week. So what you need is a year's worth of utility bills. Ideally you'd have more than one, but 1 year is sufficient. So you take the 3 lowest energy use months out of the whole year. It doesn't matter if it's the middle of the winter or the middle of the summer or the fall. It doesn't matter. You take a whole year's worth of bills, you find the 3 lowest months. Okay? So what you do is you average those 3 low months, and that's your average monthly base load. That's your average monthly base load. I'll go over an example here in a minute. And then that's your monthly base load, so there's 12 months in a year, so you multiply times 12, and that's your annual base load. Okay? So let's do a quick example. So this is a year's worth of utility bills. We have electricity and natural gas, January through December. Okay? So let's think about how we calculate. Let's start with the electricity base load. All right, so the electric base load, which is the top row. So feel free to pause and find the 3 lowest months and see, average them out and tell me what the monthly base load is. Okay? So the 3 lowest months, and again, it doesn't matter what time of year it is. It could be the middle of the winter, it could be the middle of the summer, it doesn't matter. But in this case, our 3 lowest months are these 500, 450, and 500 kilowatt hours. Find the average of those, which is pretty simple math. And there is your monthly base load of 483 kilowatt hours per month. So what that means is that for this house, you assume that you're using about 483 kilowatt hours every month, no matter what happens. Okay, so that doesn't change. And then to get the annual base load, you just multiply times 12, and you get about 5,800 kilowatt hours per year. So that's their annual electric base load, is 5,800 kilowatt hours a year. Okay, so feel free to press pause and see if you can figure out the monthly and annual base load for natural gas. Okay, so our 3 lowest months are 25, 25, and 30. It doesn't matter if you pick this 30 or that 30, they're still the lowest months. Okay, so you take the average of those, you get about 27 CCFs per month. So again, that is your monthly base load. So you assume that they're using an average of about 27 a month, 2,700 cubic feet per month minimum, and then per year that's 320 CCFs. Okay, so it's really simple. If you have a year's worth of utility bills, it's really not difficult to find the the base load. Pretty straightforward. Now, keep in mind, this is just an approximation. You don't know exactly what their base load is. I mean, they may drop below that. Who knows? But this gives you a really good sense of their baseload energy use versus their seasonal energy use. So now let's go over these different energy using appliances and ways that they use energy in the building. So what I want you to do is press pause, and I want you to go through each of these one by one: space heating, water heating, cooling, and so forth, and jot down if they are seasonal loads or base loads. Okay, so think if they are used pretty much the same throughout the year, or if they change based on the season. Okay, so first, space heating. seasonal load, right? Because that's used, that peaks during the heating season. Water heating, think about this carefully. Water heating is actually a base load. I mean, you take showers, you take baths, you know, whatever, you wash dishes all year round. Again, this can change a little bit. Maybe in the winter you're taking longer showers, who knows? But it's still pretty much the same. Okay, so cooling, of course, is seasonal, right? Because that's going to peak in the cooling season. Lighting should be a pretty easy one. We always need lights. That's a base load. Now again, this can change throughout the year. The days are shorter in the winter, so you're going to use more lights. But it's not significant to the point that it's a seasonal load. Okay, so it's considered a base load. You use lights year round. Whereas like cooling, you don't use in the winter at all. Refrigeration, right? We always have refrigeration, so that's base load. Clothes dryer. For most people, this is a base load. But some people do dry, you know, if you dry your clothes on a clothesline, then that could be considered a seasonal load if you just don't use the clothes dryer in the summer. And then the other stuff is generally a base load. This is like your TV and your microwave and oven, whatever. So the appliances that you use year round. Okay. So hopefully that gives you a sense of seasonal load versus base load. And energy auditors, as an energy auditor, we address all of them. So again, with energy auditing, you're looking at all the energy used in a building, whether it's a seasonal load or base load, and you're going to do, as an auditor, you do an analysis to figure out, okay, what's our base load here, and you're certainly looking at seasonal loads because heating and cooling costs are a major part of a utility bill, and often those are recommendations that you can make as an energy auditor. But you know, water heating is a base load. That can be a good energy conservation measure. Lighting as a base load, that's usually a really good energy conservation measure. So again, we're looking at everything as an energy auditor. It's really important that you look at all energy using equipment in a building. Okay. So on to heating degree days. This is just a basic brief introduction into heating degree days. We will get into more detail later. So for now, you just need to understand the basic concept of what a heating degree day indicates. We'll dig into the math in more detail later. So the easiest way to think of a heating degree day, it's an indication of the average outdoor temperature relative to the comfortable indoor temperature. What it means is, as heating degree days go up, well, put it this way, as the temperature outside drops, the heating degree days goes up. Okay? So the higher heating degree day means you need more heat to keep the building comfortable. Conceptually, pretty easy to remember, right? Just remember, it's heating degree day means you need more heating. Okay? Now there is such a thing as a cooling degree day, and that's the inverse, and that is where you need more cooling, right? So you have more heating degree days in the winter and more cooling degree days in the summer. Okay? Again, I'm going to go over this here just to sort of put the bug in your ear, but we are not going to calculate heating degree days yet, but we will do this later. So if you want to calculate it for one day, what you do is you take the temperature basically the temperature that you want to heat the house to, called the base temperature, and then you subtract that from the average outdoor temperature. So the standard base temperature, and this, you do want to jot this down, so you should jot this down, that the standard base temperature for a residential building is 65 degrees. So you probably are aware that 65 degrees it's not a particularly comfortable temperature for most people. That's a little colder than most people like it in a house. The reason we use 65 degrees as a base temperature is we assume that as long as you heat the house up to 65 degrees, that the heating loads inside the house, the things that are generating heat, so people in there, we're all generating heat. You have equipment, you have lights, you have television, even people that are cooking, you're taking a shower, whatever. So there's all kinds of stuff inside of a house that generates heat. In addition, sunlight in the window, so sunlight comes in, right? So even on a cold winter day, radiant energy will come in through the window and heat the house. So you really only have to heat the house to about 65 degrees, and then everything else, all the internal loads, will all heat it up to right around 70 degrees, 68, 70 degrees, which is what people generally consider as a comfortable temperature. So that's why we use 65. We don't actually generally want a house to be 65 degrees, but we just have to heat it up to 65, and then it'll warm up the rest of the way from there. So you take normally 65 degrees, you subtract it from the average temperature that day, and that's how many heating degree days you have that day. Pretty straightforward, right? So let's do a quick example. So let's say it's 40 degrees. The average temperature outside over the course of a day is 40 degrees. We're going to use a base temp of 65. 65 minus 40 is 25. That's it. That's your heating degree days. And then, so what you can do is you can take the heating degree days every day of the year for a particular climate and add them all up, and that's your total HDD for the year. You can do it for any period of time. You can do the heating degree days for a week, for a month, whatever. But a lot of times, most of the time, what you'll see is HDD expressed in how many heating degree days over the course of a year. And the reason we do that is because it gives us a sense of how much heating we're going to need, and it actually can give us, we can do some approximations using HDD to figure out how much heat we're going to need to provide to the building in order to keep it comfortable throughout the year. Okay. So just to give you, these are actual numbers from 2017 in Wilmington, Delaware, and it shows you the HDD each month based on the actual temperature. This is from historical data in 2017. Okay, so this is January, February, March, and you can see January we have a little over 800, then it drops to 600. It must have been a cold March because the HDD is higher than February. All right, so more HDD means a colder average temperature, and you can see it drops April, May, June. So even there are some days, even in June, where it's a little below 65 degrees on average. You're going to have heating degree days during those days. And then it goes, of course, drops and then goes back up. Right? So this is your monthly HDD in Wilmington, Delaware for 2017. And then if you look at an overall chart of HDD in the US, this I think should jump out at you right away. That, you know, purple is your high heating degree days, right? This is your annual HDD. So about 11,000 HDD up here in northern Minnesota, North Dakota. It's colder up there, right? Northern Maine. And then you notice you have these pockets here, which hopefully you have enough of a sense of geography to know that this is the Rocky Mountain region. And so those are high elevation. It gets really cold in the winter, the high elevation, so you have your more HDD. Whereas you get down to Florida, right? And it's 1/5 or less of the HDD of northern, the northern United States, which makes sense. This is basically a climate zone map, right? But this is actual HDD. So anyway, the point of this is for you to understand that with heating degree days, the higher the heating degree days, the more heat you need to keep the building warm, all else being equal. And again, we'll get into a little more detail about that a little bit later. So the last concept I want to go over in this presentation is home heating index. Now, home heating index is admittedly an imperfect metric, but it does give you a sense. Okay, it gives you a sense of how efficient a building is. And so the home heating index kind of gives you this sort of like general benchmark of how efficient a building is. It just gives you an idea. It's just one sort of tool in our toolbox. So the calculation is pretty easy. The math is pretty easy. You just have to to put these numbers together, you have to know what you're talking about. So to calculate this, what you do is you take the annual heating load, okay, annual heating load in BTUs. You divide that by the square footage of the house, and you divide that by the heating degree days. Okay, So you're gonna, in order to do this, you need to do a utility now. So you need to determine the heating load in BTUs. You need to do a utility analysis, right? And the heating load is the same as the seasonal heating load, right? So you need to figure out the base load during the heating season, and then figure out the rest of the energy use during the heating season. And the difference there is your heating seasonal load. The square footage you can get through, you measure it when you do your energy audit, or you can do partial search or whatever. Heating degree days, I actually posted a video how you can do that. There's a free online software called degreedays.net that you can use to get heating degree days for just about any location in the United States. So I want you to think about this equation here and think what it means. All right, so we have BTUs of heating divided by square feet times your HDD. So if you think about what this equation, this really basic equation does, as the BTUs go up, the home heat, if you hold everything else equal, right, the home heating index goes up, right? So if you have, let's think you have two houses. They're the identical square footage in an identical location. Okay, so the HDD is the same. So that means this whole bottom part of the equation is the same in these two houses. But one house has twice the BTUs of heating as the other. Okay, same size, same climate, but has twice the BTUs. And then remember, this is just for heating. So what does that indicate? So think about what that indicates. That indicates that that house is inefficient, or it's using a heck of a lot more heating than the other house, right? So if these other two, if everything else is equal, but one is using a lot more heating energy, that means you're going to be higher on this HHI scale, right? Your number is going to go up. Up means less efficient, okay? Whereas the other one is going to be lower, so it's going to be more efficient, right? So that's one important aspect of this. Another thing that's important to consider is, why do we divide by square foot in HDD? So if you think about it, if you have a really big house, right, you have more square footage, which means you would expect your BTU number to be lower, right? So if I have a 1,000 square foot house versus a 2,000 square foot house, I should use about twice as much heating in the 2,000 square foot house. Well, if you divide by square footage, what that does is sort of cancels out the impact that building size has on your heating. So if you divide it by the square footage, that sort of evens things out for you. In HDD, it's the same principle. So if I have two identical buildings, one's in Florida, one's in Maine, right? So you would expect the one in Florida to have a lot lower BTU of heating, right? Well, guess what? The HDD is also going to be lower. Remember, on that map, Florida has about 1/5 of the HDD of Maine. So if the HDD is lower, you would expect there to be less heating, which means that BTU number will drop. Again, the whole point here is, by dividing by HDD, it sort of cancels out the impact of climate on your heating costs, your heating energy use, excuse me. And what you do is you apply that formula, and then you find where you are on this scale. And the scale is also in your book, by the way, and it's on the lab for your lab today. You find out where you are. If you're 8 to 13, it looks like you've kind of some good opportunities. If you're up here 18 plus, 22 plus, you really probably have a very inefficient house. So the point of doing this is not that it's a surefire way to determine if a building's efficient or not, but it does give you some sense of how efficient a building is. Okay, so that's it for this presentation. We went over the difference between seasonal load and base load and the different examples of each. We went over how to calculate each of those. We looked at basics of a heating degree day and how to calculate a home heating index and use it to analyze the basic efficiency of a building with a utility analysis.